Hi friends, welcome to the Arduino tutorial series developed by Tishitu Research Center Jaipur. In this video, we will do a basic Arduino example of reading analog voltage. So let's get started. For this experiment, you will need some components which are a A/B standard USB 2.0 cable whose one end is connected to the PC and another end is connected to the Arduino Uno. This is breadboard. The main advantage of breadboard is its reusability because using this we can make the circuits without soldering the components. These are male-to-male breadboard jumper wires. Such wires have pin-type connectors on both the ends instead of socket one, and these are used to connect components with one another or one circuit to another circuit. A multimeter. This device is called a multimeter because it has many meters inside it by which we can measure capacitance, resistance, current, AC voltage, DC voltage and other electronic properties. These are variable resistance. They are also called potentiometer, pot, preset, etc. They are three-terminal device with a sliding or rotating contact which acts as a voltage divider. Thus they reduce current in the circuit same as a resistance, but these are variable resistance. These are used to regulate speed of the fan and were also used in old analog radios to control the volume. Screwdrivers are mechanical devices which are used to loose or fasten a screw. And Arduino Uno R3. Let's start our experiment. These are the components which we need for experiment. A multimeter and multimeter wire, breadboard, potentiometer, male-to-male jumper wires, Arduino Uno and USB wire for serial communication. So let's start making the circuit. Firstly on simulation. So let's open Proteus ISIS. Proteus ISIS is an awesome circuit simulation platform and its library includes lots and lots of electronic components, so you can simulate all possible circuits on it. Click on Proteus part list and in keywords type Arduino Uno and select Arduino Uno R3. Click OK and place Arduino on the design. Now let's open Arduino code compiler. Go to Files, Examples, Basics and select Analog Read Voltage. This is the code, and in this code we will read analog voltage from pin A0. So for this we need to connect the center pin of potentiometer to pin A0 and other two terminals of potentiometer will be connected to 5 volt and ground. In void setup loop there is a function serial.begin to initialize handshaking between Arduino Uno and your computer at 9600 baud rate. In void loop we have an integer sensor value which continuously stores the value returned by function analog read. Now analog read reads the value of pin A0. The sensor value will be between 0 to 1023 as analog read reads the bit values, and to convert it in the form of voltage we need to multiply it by 5 divided by 1023. So it is basically a sort of calibration which converts the range of sensor value to 0 to 5 volt. In the last line serial.println prints the acquired voltage on serial monitor. So now let's start making circuit on simulation. Open Proteus ISIS again. In Proteus, click on part list and type POT-HG, and from the list select active potentiometer. Click OK and place it on the design. You can rotate the component if you want. Right click on the object to edit its properties and set the resistance to 10 kilo ohms. Okay, now we need a ground terminal and a DC power source. So click on generators and select a DC power source and connect one of the fixed ends of potentiometer to DC power source. Right click on it and set the voltage value to 5 volts and the other fixed terminal of potentiometer to ground. Now from instruments, let's select a DC voltmeter and the negative end of the voltmeter should be connected to ground and the positive should be connected to the output terminal or the variable terminal of potentiometer. Okay, now my simulation is giving error because there is no file in microcontroller. So let's compile the program, and once it has finished compiling, we should scroll to the bottom right corner. These are some libraries, okay, that it get installed. These are usually to prevent bugs. Okay, scroll to the bottom right corner and copy the location of the generated hex file by keyboard. Press Ctrl C to copy it, as mouse will not work here. Now again right click on Arduino and in program file paste the path of the generated hex file, click OK, and okay, I think it's okay, and again play the simulation. This is the basic circuit. To notice the voltage variation, as I click on the negative button, the variable terminal shift towards 0, and as I click on positive button, the variable terminal starts advancing towards 5 volt, and same variation can be seen on voltmeter reading. Okay, to make the things clear, let's select a voltage probe, but firstly we need to stop the simulation and now place a voltage probe. As you can see, the left side of potentiometer has a static voltage of 5 volt, which is denoted by voltage probe. Now let's connect the Arduino pin A0 with the variable terminal of potentiometer and again play the simulation, and notice that as variable potential reaches 0 or is towards 0, the color of the box is blue, and when it is exactly in the middle, that is 2.5 volt, the color is gray, and if it is on the extreme positive, that is 5 volt, the color of the box is red, and same effect is noticed on the box near variable terminal and A0 pin of Arduino. The TX or transmit data pin of Arduino is blinking continuously, which denotes data transmission. So let's attach a virtual terminal to see the data. Connect the RxD pin, which denotes receive data pin, to TX pin of Arduino, and the virtual terminal and voltmeter shows the same variation of voltage from 0 to 5 volt. You can use the same circuit and logic in different data acquisition tools such as MATLAB and C#. So experiment with it, and now we are ready to implement it on the hardware. So let's get started. Firstly, I have taken two male-to-male jumper wires. The green color denotes the negative terminal and yellow denotes the positive. So green wire is to be connected to the negative terminal of multimeter, which is black in color, and the yellow one is to be connected to positive terminal of multimeter, which is red in color. As you can see on the upper right corner of screen, usually the multimeter terminals are of pen type, but we have customized it to crocodile type probes to make the connection hand free. Now let's take another three male-to-male jumper wires. The white wire is to be connected to center pin of potentiometer and pin A0 of Arduino. The gray wire is to be connected to 5V pin of Arduino, which is VCC, and to one corner terminal of potentiometer, and the black represents ground, so it is to be connected to ground pin of Arduino and to the another corner terminal of potentiometer. Okay, now let's connect the potentiometer. Remember that the center pin of potentiometer should be in line with the white colored wire. Now let's connect the green and yellow wire to the multimeter probes. The green wire is to be connected to the black probe and the yellow wire is to be connected to the positive or red probe. Now here is a very important step, which is you should adjust your multimeter to DC 20 volt, because if you have set the multimeter to a lower range such as 2 volt and we are measuring a higher voltage, then it may get damaged. As you can see, when we rotate the knob of the potentiometer, the readings on the multimeter change from 0 to 5 volt. My multimeter has a zero error of 0.02. Anyway, the circuit is ready, so now let's upload the program. So again, open Arduino code compiler and the example of analog read voltage from basics. You can also continue with already opened example. Anyway, click on upload button, and as the program is uploading, notice that TX and RX LEDs on Arduino board blink. Okay, now open serial monitor. Okay, now the multimeter and serial monitor will show the same voltage reading. There might be a small variation, but almost it would be correct. So henceforth the example is complete. You can use the same example for making data acquisition tools, SCADA system, computer interface programs, remote data acquisition tools, and you can also combine this logic and concept with new technologies like Internet of Things and Li-Fi. Keep on watching our channel for more updates. Hope you enjoyed the video. For more informative videos like this, please like, share and subscribe our channel, and also share your valuable suggestions and queries in comments below. Thanks for watching. Bye.